So, hello and welcome back. I've been continuing on the 3D printer and I made some progress, but as you can see from the different colored pieces on the build that I had to reprint some parts, and I actually ran out of red filament. Which in a way is cool because now we can see the changes in the parts and we can see the progress that we're making. I also went out and purchased screws of the correct length, and I redesigned some of the parts so these screws would fit perfectly. Basically, it's just making sure that if you have a 16mm screw, that there's enough of a hole that it screws in all the way. And some parts will still need to be reprinted, like the motor mounts, because for them this is just simply not the case right now. I'm looking a bit into improving some of the construction of the axis, and maybe I'll rework the extruder mount, but right now this is the best solution that I could come up with. I did build another one that was basically completely suspended on magnets, but that didn't work out so well, just because the quality of the 3D prints just isn't good enough. And since the 3D printer is supposed to be a printed forward machine where you can make all the parts on the 3D printer itself, it wouldn't make sense to use SLA printing, like resin printing, for these parts. I still have to figure something out. The tap switch works reasonably well. The only problem is that if I press down right where the posts are, it is very easy to press down. But the further I get away, the more load I get in a different direction on these rods, and the ABS just becomes very sticky. I think it's going to work out with where the extruder head is right now. Let's just try it out. If this doesn't work, then I may have to go back and make a different mount that has real brass sleeves going over the rods. Maybe that can improve it, or I can even go for real ball bearings. But if I have ball bearings here, then the space remaining for the switch and the X-axis home switch is going to suffer a lot. So right now this is the best that I can do. I want to go ahead with having a tap sensor. Don't know if I'm going to be able to make it across the finish line with it. Yeah. Apart from that, I did add a Z-axis limit switch right in the back of here. It's a Y-axis limit switch, of course. This will be probing to the maximum position. Of course, the X-axis switch is on the minimum position side. When everything is finished up, this switch will be moving over to the other side, and this block over here will be slightly modified so the switch can probe on that side. So we have maximum switches on both sides of the 3D printer. But for a start, I can just fix this in software. Yeah, also I went ahead and I bought the aluminum material that I need. which is really handy because I can order it on eBay, and the shop that is cutting them is only 15 minutes away from here. And they have a very good saw, and their ends are perfectly 90 degrees in all directions, and they're very, very nice to work with. So I have that. So for the next part, I can probably get into making the frame and getting the frame assembled. The last thing that I did was on this side, I changed out the linear rail and block because this one was moving extremely bad. These are all leftover rails. They were either left over from other printers, or they were just, I don't know, they were too bad, or I put them aside. All of the stuff on here except for the screws and the extruder are basically leftover parts, and yeah, I'll just go with that for now. Also, I had all the belts mocked up in the way that they are going to go across the frame. So from the extruder, we're going over to the front, then to the stepper, then we're going back, moving over and back to the carriage, and on the other side it's just the other way around. It's a pretty standard Core XY. Because of the leverage forces on these parts here, I was debating if I should have the belts on the back switch over from top to bottom, bottom to top. That would mean that I can have shorter levers here, and I can just move the belts closer to the rail. Not doing that right now, but let's keep an open mind in that direction. Apart from that, that was basically it. Oh yeah, of course. No, it wasn't. I also mounted the steppers, and I made sure that the steppers can be mounted this way. So this one has the drive pulley mounted upwards, and the other side has the drive pulley mounted downwards. And everything fits, and everything is long enough, so no problem with these parts. Yeah, that's about it. I think those are the changes that I went through, and I'm really looking forward to getting it attached to the frame. I think I went back and forwards about 10 times, measuring exactly how wide the printer is and how much space I need back to front. I think I actually made the aluminum part for the y-axis, the one that is parallel to the y-axis, a little too short, but for a first iteration, yeah, that can happen. And it's not going to be a problem with the print bed. Also, I went through my stash and I found a print bed that I can use for this. I just have to make sure that any mounting holes that are on the print bed line up with something where I have aluminum to tie it to. But I think we can make that happen. So that would give us a 24 volt print bed. Oh yeah, and of course the whole printer is going to be 24 volts. Okay, so that's it for this printer for now. In the last video I was talking a lot about the original Robin 3D printer, or the Bad Robin in this case, and I never showed one. So this is basically my presentation 3D printer. Like I said, it is made up of 18 3D printed parts. It is a printed forward philosophy. It is, apart from that, based on parts that you can buy online easily. Like it has an Arduino an Arduino Pro. It has a ramps board. It has standard steppers. It uses cheap linear rails. It has a V6 extruder. Usually it would have a TiVo Titan Bowden driver on this side. This one doesn't have it because it's just for showing off the concept. It uses standard bearings to move the belts. Everything is very simple. But because everything is very simple, that makes these parts very light. And because all the parts are very light, this printer can go reasonably fast. The x-axis can have acceleration values up to 5,000, the y-axis up to about 4,200. The z-axis can do hops very quickly, and if you ever run into anything, the z-axis is open to the top, so you can actually run into something and it will push up the z-axis and not totally ruin your hot end. Apart from that, it is designed so there are no edges where you would have a structural part on the bottom and your bed would fling towards the front, and where you could get your fingers into. The original Robin does not have a heated print bed. So the next things that I'm going to do now are I am going to get the aluminium parts drilled. They will be held together by threaded rods that go through the parts, so there will be M6 threaded rods inside of the mid parts, and it will just pull everything together. That way, if it gets out of alignment, you can just open up the nuts, push it down on a flat surface, tighten the nuts up again, and the 3D printer will be set up and ready to go. I used this on the other Bad Robin, and it was a very good solution. Also, it makes the assembly and disassembly very simple, and you can use you can reuse all of the parts that you have, just in case that this project doesn't go the way I want it to. Yeah, I think that's it for this video. I'm going to start setting this up, getting things drilled. I don't think I have to go out and buy a lot of parts. I think I have everything here. So we should see some progress soon. Thank you very much for watching, and bye-bye.